In the remainder of this unit, we're going to be looking at various amplifier circuits. For our BJT, because it's a 3-terminal device, we're going to see that we have 3 basic configurations depending on which of those terminals is at signal ground. And so note here, we're specifying that this is signal ground, not necessarily a physical direct line to ground. And so the 3 configurations that we're going to look at in turn, one is going to be our common emitter. And so we've actually already seen this configuration previously in our previous unit. And so this is common emitter. Our second is going to be our common collector. And as you can probably guess, our third configuration we're going to call our common base. And so of course common is just indicating that that connection is to ground or signal ground. So our first one, our emitter, is going to be at signal ground, our collector at signal ground for our second one, and for our third one, our base at signal ground. And so we'll also see that this second one, our common collector, will also commonly be called our emitter follower. And so why that is, we'll see a little bit later on as we learn about some of the characteristics of it. Okay, so now we have these 3 configurations. So each of these 3 configurations can actually be represented as a 2-port network. So each of our 3 basic configurations above can be represented as a 2-port network. Okay, so now the 2-port network, though, has one of 4 configurations. So 4 possible configurations. And basically just is because we can have an input that's a voltage or an input that is a current. On our output side, we can also have a voltage or a current. So what that gives us is 4 possible combinations. And so you can see details of that on page 397 in the textbook, and there's also going to be a handout posted in Canvas. But basically, to summarize real quick, what we have is we have 4 different amplifier types based on those 4 different configurations. So as you can see, we have our voltage amplifier, our current amplifier, our transconductance amplifier, and our transresistance amplifier. And so which amplifier we have depends on what our input and output signals are. So for our voltage amplifier, our input is going to be a voltage. Our output is also going to be a voltage, and the relevant gain is going to be our voltage gain, which we're going to use the signal A sub V naught. For our current amplifier, similar to our voltage amplifier, we're just going to have current in, current out. So current is our input, current is our output, and our current gain, we're going to use the symbol A sub I naught. Now we're going to switch it up a little bit for our transconductance amplifier. So here we have an input that is a voltage. We have an output that is a current. And so our gain, we're going to use the symbol G sub MO. And then we're just going to flip those inputs and outputs around for our transresistance amplifier. So we have an input that is a current, an output that is a voltage, and our gain symbol is going to be R sub MO. And so as I mentioned, what we're going to do in the following videos for pretty much the remainder of this unit is look at these 3 configurations. And so if it's helpful, there is a summary table towards the end of the note set in Canvas. So you can kind of be looking at that to know what characteristics each of these configurations is going to have. Or if you prefer, you can just look at each of the configurations as they come and then use the table sort of as a review to summarize what we've looked at.